In this unit, we're going to talk about the different types of chip technology on the LED flexi strips. And it's important to discuss there's nothing like old technology and new technology. They both have their advantages and disadvantages. A lot of people now, because of marketing, are saying, oh, these are the best strips because it's uniform lighting and people don't like the dotting. But depending on the application, we can get better light and power output out of our SMD strips. Just to name a few of the differences and why we shouldn't dismiss the two technologies, but we should understand them and understand their benefits. The SMD stands for surface mount diode. So these diodes are soldered or mounted onto a printed circuit board like this, along with the resistors. And at the right angle, you may be able to catch the imprint of the circuit board. This is one of the most common type of strips or type of applications used in the LED lighting industry. We use surface mount diodes on the floodlight. I showed you earlier. Some bulbs use a lot of surface mount diodes. So it's a very common technology. They come in various shapes and sizes. You probably heard of SMD 3528, 2835, SMD 2116, SMD 5050. All these mean is the packet size of the LED chip. So this LED here is a SMD 5050. You can see it's 5 millimeters. And then if I take the other measurement like this, if I measure this dimension, it is 5 millimeters. So this is how we got the name SMD 5050. 5 millimeters by 5 millimeters. Now, another feature of the LED chip, the SMD 5050 has a circular output, and you could see the output surface is a rectangular as opposed to a circle. All chip sizes have different efficiencies, and manufacturers put this together to come up with the perfect light. Now, do bigger chips mean more light? Yes, it does. Does it mean it's more efficient? No, because you could use smaller packets that are more efficient, and you can make them more dense, and they could be double or triple the brightness of a regular 5050 LED. So don't create your rule of thumbs. Price also plays another factor in manufacturers trying to get the most efficient LED light at the best price. So this is another example of LED density. You can see there are more SMDs on the PCB above than the PCB below. So before we move on to the Cobb technology, and I explain what it is, there's been a chase for light and uniformity. So people like the idea having a uniform light when we put this cover on. And in order, if you look at the cover faintly, you could still see dotting. So in terms of LED density, if I had this in a cover, in a fixture like this, you're definitely going to see the hotspots of the diodes as opposed to this one and opposed to that one. Before I compare and contrast the difference between these two, let me talk about the Cobb technology. Cobb stands for circuit on board, and it refers to a technology where the LEDs are directly packed onto the circuit board. On top of those chips, you have a spread of phosphor that covers those chips. You could see that the LED chip is directly packaged onto the printed circuit board. Unlike the traditional SMD LEDs, which have a bead holder to hold the phosphor in little wells above the chip, COB LEDs eliminate that component, leaving only the chip and a yellow phosphor coating spread along the top of the PCB. This minimalistic design enhances the efficiency and gives a wonderful appearance for minimalistic lighting. Just to close off what we just spoke about, I'm going to highlight the major differences between the two of them. SMD, individual chips on the PCB. COB, chips are directly mounted onto the circuit board continuously. Appearance, dotty, in some circumstances, very dotty. Uniform. Uniformity of light, they're both pretty high, but if the LEDs were spaced out further in this one would naturally have the best uniformity of light. Applications, they can both be used, but if you want to use a application without a aluminum housing and you want that continuous neon-like look, this is your choice of LED. Flexibility in aluminum profiles, ultra high. Flexibility in aluminum profiles, limited, because if the aluminum profile is very thin, you may pick up dotting. This one is very rare to pick up dotting, but if I had another SMD strip, you would see dotting. Brightness output for similar specs. Winner, this has a light emittance angle of 120 degrees This has 180 degrees, so we get more direct light out of the SMD. Stability and reliability. This design eliminates the fragile gold wires in the makeup of the SMD. So this light tends to be a little more stable. I think newer technologies now are even boasting you could step on this and twist it in any way and it's not going to break the circuit board. These ones do have very sensitive circuit board designs, especially if it's not made from good quality. Illumination angles, narrow as I mentioned, 120 degrees and just wide. Stronger anti-static. This is like almost like a rubberized phosphor coat. This has a higher anti-static capacity than this one. Color consistency. It's difficult to maintain color consistency due to the lack of binning machines for the COB. And just on a side note, let me tell you what binning is. Binning is the process of sorting and grouping LEDs based on performance characteristics like color, brightness, and efficiency. This ensures uniformity, quality, and consistency in LED lighting products. So the key benefits of binning: improve color. So what the machine does, it sorts all the LEDs, looks at the color temperature and the variations, the big variations, it takes them out. They may look at other factors, but overall, what that does, it sorts the LED production line into different bins of quality. And they use that consistent bin for maintaining a production line of LEDs in the future and in the next batches. Another disadvantage is luminous efficiency. Even though this technology, the COB technology, is emerging, we still have higher luminous efficiencies out of the SMD technology. I'll see you in the next module to discuss quality in flexi strips. I think that's the main thing that people want to know. How do you know what's a good flexi strip and what's not a good flexi strip? Or how does quality impact the flexi strip? I'll see you in the next unit.